September 19th, nearly the official start of fall, and we have a narrow window of time to install a frost tube before the ground freezes and it's harder to put a pipe like this into the ground. I'm Christy Buffington, a Globe teacher and trainer at the International Arctic Research Center at the University of Alaska Fairbanks. I'm also a former middle and high school math and science teacher. With me is Chelsea Huckbody, an exchange student from the University of Wisconsin-Stevens Point, who is doing an undergraduate project on frost tubes. Join Chelsea as she learns to make and install a frost tube for the first time. You can make your own with a few supplies. All of the supplies here cost me under $20. First, let's learn about frost tube and how we can monitor frozen ground using a frost tube. And what is it? It's an instrument used to measure the depth and the timing of the freezing of the soil. This frost tube that you see here consists of two tubes nested together. I'll take the cap off, and you'll see that inside is a tube with colored water. I marked the ground surface a 0 here, and every 5 centimeters another line with tick marks in between. So it's easy for students to pull this out and measure the depth to freezing. The outer tube that you see here consists of PVC pipe, and it is capped or sealed on the bottom under the ground. And then we also have a cap that goes on the top. And that cap is keeping debris out, it's keeping rain and snow out, so that this inner tube doesn't get stuck. But basically, you probe the ground, and if it's soft enough to put the stick in, that will help you decide where to put the frost tube. And you also measure this depth. So in Alaska, in places with permafrost, we need to know how deep to install this frost tube. Go ahead, Chelsea. And then back down. And it feels like you hit a rock. Except for we're in an area with permafrost. It means that she didn't hit a rock. She actually hit permanently frozen ground that's frozen for over 2 years. And that's the depth that we'll be able to install a frost tube. So what we'll do is mark this depth and measure it at 61 centimeters, which is really interesting because this frost tube goes 2 meters below the soil surface, which shows how variable permafrost is.
So why does the frost tube stick above the ground when we are trying to observe what happens below the ground?
That's an awesome question. So 1 meter of the frost tube is above the ground, so it can stick out above the snow. It also has a cap on it to prevent the snow, the water, and the debris from entering. So in the frost tube, this inner tube, the colored water will show what's happening to the ice and the water as the temperature starts to reach 0 degrees Celsius. When the temperature is 0 degrees Celsius under the soil, the water that freezes will be clear and it will push the dye out. And the part that's frozen will be clear, the part that's still liquid will be colored. What the students do is they measure from here. All of this, when it's cold, because this is all above ground, will be clear and it will be ice. The kids love to go like this to it because it cracks and crunches because it's frozen ice. And then from the ground down will also be frozen until they see a very clear boundary between clear ice and colored water. That boundary is the depth of freezing as the ground cools. So here's a definition of the depth of freezing. It's the distance in the inner tube of the frost tube from the soil surface to the boundary between the ice layer and the colored water. This boundary represents freezing, measured from the soil surface down. It freezes from the top down because air temperature is what's causing the soil to get colder and colder and eventually to 0 degrees.
I want to know why frost depth matters.
Thanks for asking. The depth and timing of seasonally frozen soil affects hydrology and construction. It affects plant growth and agriculture, soil process. Where you live in Wisconsin, it affects the amount of load that can be on the roads, and sadly, it even affects burials. You can find the temperature of the soil without using a thermometer like you have here. This is an air thermometer, an air temperature, and you can also use this for water, but not for soil. So it's really great to be able to figure out what the temperature is in the soil at various depths, whereas our globe soil thermometers really are used for 5 and 10 centimeter. Years of frost tube data will help us to know about the soil microclimate and how that's changing so we can make connections to a region's climate.
Cool. Is the frost tube protocol just for Alaska?
Like I mentioned, in Wisconsin, it actually determines, how much weight can be on a road, and then those weight limits are removed in the spring, because in the spring a road surface is really susceptible to frost heave. So absolutely, frost tube is really relevant in Alaska and in any place that has seasonal freezing and thawing. Ideally, the Globe Frost Tube study site should be like here in a relatively undisturbed, uncompacted soil and of native vegetation, not next to a road. So we mentioned permafrost. In Alaska, we have places with permafrost. You don't have permafrost in Wisconsin, do you?
Nope, no, we don't.
Interesting. So scientists all over the world are interested in permafrost because its thawing is due to increased air temperatures. So the frost tube in Alaska is studying the active layer. That's the layer that we're standing on that's above permafrost. It seasonally freezes and thaws, and all the microbes in this layer are constantly working on organic matter within that soil. So we really need to know what's happening to thawing permafrost, but also to the expanding active layer in Alaska. NASA scientists and also scientists at the University of Alaska Fairbanks want to know what's happening in the active layer. We're asking questions like, how deep is it frozen and how long? Once you've installed your frost tube, every year in the late summer or early fall, teachers should go out and check this inner tube and also the outer tube. They should be able to pull it out and push it back in and compare if the distance from the ground surface to the bottom of the frost tube is the same. Because maybe the earth has settled a little bit and they want to make sure that it's the right length. The other thing that they should do in the fall is they should bring this inner tube all the way out to the very bottom. Oh my gosh, feel that. So it's starting to freeze and the color is changing. Pretty soon this is going to push the blue dye out because you can feel that that's already freezing. And that shows, this freezing shows that there's permafrost at the bottom of the tube. So we determine the maximum depth of thaw of the active layer, and we can enter that data in Globe once a year, every summer. Look for ice present at the bottom of the tube. It's still blue here, but it's definitely frozen. You can feel it. And we're gonna measure that depth. So right now, we would write down this depth. NASA's conducted airborne and satellite missions to determine the depth of thaw. So students and teachers can compare that local data that they just found, that we just found in the depth of thaw, and compare it to the NASA satellite and above airborne missions. So here's an important thing to remember. I know it's a lot of information, but what we're doing right now is probing the depth to permafrost, and we only do that once a year. We're not going to do that in Wisconsin because there's no permafrost there. We're only doing it in places with permafrost to see how that permafrost is changing. The take-home message, though, is when students monitor the depth of freezing, they are measuring the depth from the ground surface, not from the frozen permafrost below and up.
So how often should students check the frost tube?
Just once a week.
Cool.
Both Alaska and Wisconsin are good places for Globe teachers and students to monitor the depth of soil freezing. Read the protocol, do the new FrostTube e-training, and check out our next video to learn how to make and install a frost tube. If you haven't already, watch the NASA Explorers CryoKids episode that shows students in Venati, Alaska checking their frost tube. Thanks for listening. Chelsea,
Let's do science.